This is brought to you by the Alumni Association of PISJ-ES.
Hey guys, today we will be starting up with a whole new topic, and this is one of the very vital or very important parts of physics, and you should have a very good understanding of this topic. We're going to be talking about forces. So first of all, let's talk about what do we mean by a force. Generally, if you just talk about force in just a layman term, it would simply be a push or a pull. For example, this is an object, and I'm standing here. Okay, this is weird, but yeah. And I just push it with my hand, like this. I would say that I am applying a force on this. Also, there could be a case where this is the box and I attach a rope to it, and I'm standing here and I just simply pull this rope, and you would know from your daily life experience that this box will move in this direction, and so I'll say that I am applying a force again. But when we're talking about physics, or as in technical terms, a force is not simply a push or pull. Force is an influence that can change the direction of an object when it's moving, the direction, and let's say the geometrical construction of the object, as in its dimensions and all, and also its shape. So a force is simply an influence that can change the direction, the geometrical constructions, and also an object's shape or its speed, and any quantity that is related to an object's motion. A force can change that, except for its mass. A force cannot change an object's mass. Mass, remember, is unchangeable. So this is force. Now let's see some examples how it's changing. First the direction, then the geometrical construction, and then the shape and speed and everything else. So let's talk about direction first. For example, you have a ball coming towards you and you are playing football or soccer. This is a ball coming towards you this way. What you do is, here is, or let's say here is the goalpost. Here is the goalpost, and you have to put the ball right here. What you do is just kick the ball in this direction. So what happens that it was moving in this direction earlier, and when you apply a force or when you kick the ball starts moving in this direction. So in this way, your ball just changed the direction of because of your force. So a force has the ability to do that. Now let's say shape. How does it change the shape? For example, if you have a piece of paper, this is your piece of paper, and something scribbled here. All you do is you just roll this piece of paper into this little ball here, and you were playing a paper ball something in your classroom, and you just roll it here. So what do? You push it from this side and this side, and then from this side and this side. So basically you are applying force in all of the directions to make it a ball like this, and then you continue with your playing. So in this way the force is altering shape of an object. Let's say let's talk about the size of an object. Let's say the size of an object. Now let's see you have a clay figure. Okay, you have a rectangle or a cuboid made purely out of clay, and you don't want this. So what you do, and this is not the right height, so what you do, you just simply press it from here and here, and suddenly it just shortens in height, because this was made of clay obviously. So it was an easy example, but you applied forces on in one direction, in opposite direction, sorry, and you just change the size. And you can also change the speed of an object. Like for example, if you were here and a ball is moving towards you, and suddenly as it's moving you just catch the ball in your hand. Or let's say you have, this is a tennis racket, and there is this tennis ball coming your way. All you do is just hit the ball. So let's say initially it was coming at a velocity of 10 meters per second. There is a very high probability that when you hit the ball, the velocity will not be 10 meters per second anymore. It might as well be simply 12 meters per second final velocity, or let's say it might be 15 meters per second. I don't know, but we can calculate it using the methods that we will see in the next lectures. But the point is, the speed has been altered just by flicking this tennis racket and applying a force towards this ball. So you have altered the speed of the object. So a force can alter all of these quantities and even more. So that is a force. It's an influence. Always remember. Now let's see the types of forces that will be. There are two types of forces, and we will be seeing both types separately. The first ones are the contact forces. The second one is the non-contact forces. Now, examples of contact force. What do you mean by contact force? A contact force is only exerted when two objects are in contact. Otherwise, they can't exert force on the other object without being in contact. Now, let me tell you an example here of a contact force, and simply the definition of a non-contact force is the kind of force that is exerted without any contact between two objects, without a physical contact between two objects. For example, here's a desk, okay, and you just move this little piece here over, and you slide it over the desk. There would be a point where it will come to a stop. So what caused it to stop, and as in what happened? Why did it stop? Because there was a force on this object. and the force wanted this object to stop. And this force we call as friction force. But unless the two objects are in contact with each other, they will not be able to experience frictional force. Unless the object is on the table or on some, or it's in contact with another object, it's not going to be able to experience friction force. So basically, friction force is a contact force. We will see this in detail. The second one is air resistance. Air resistance is again very similar to the friction force. It's let's say it's just friction force in air. Friction force in air. And you might say that when I explain this to you, you might say that this is not a contact force, but it is a contact force. Now I will tell you how. And let's say the third contact force is the thrust, which is simply a push and or a pull. That is again a contact force. If you want to push or pull an object, you cannot do it unless you have some kind of contact with the object. So that is again a contact force. Now let's come to the non-contact forces, and we experience these in our everyday applications. But since we might not know about them, we don't take them as very important quantities. Let's see. The first one would be gravitational force. Gravitational force is simply the force of gravity on a mass. It's simply the amount of force. For example, if this is a mass, and gravity is like it knows everything, and let's say it's just exerting a force on every mass that exists in this world, or even in the outer space. So gravitational force is simply the force exerted on every mass, but the object does not need to be as in placed on the earth to experience gravitational force. It can be in the air anywhere, it will still be experiencing gravitational force, which is why it is called a non-contact force. A contact is not required, and this is a very important force in our course. The gravitational force, the friction force, the air resistance, and the thrust. There are also other forces, for example electrical force, which needs no contact, and again there is a magnetic force, but you will not be studying these one in detail in your IGCSE physics.